Okay, so in this video, we're going to practice using the chain rule specifically with trig functions. And this is going to be a good problem because you're going to see that a lot of these problems look pretty similar, except for where the parentheses are grouping, the expressions within the whole function. So let's go through them. So the first one we have y is equals to cosine of 3x squared. So when it's written like this in textbooks, and they usually don't put parentheses around, that means the inside function is a 3x squared, and the outside function is a cosine function. So pink. So if you want to find the derivative of y with respect to x, so dy dx, we take the derivative of the outside function, so the derivative of the cosine function, which is the negative sign, of whatever that is, negative sign of 3x squared. And then from there, we multiply it by the derivative of the inside function, so the derivative of 3x squared, which is 6x. And this is our answer. We can just clean it up a little bit. So we have negative 6x times the sine of 3x squared. All right, next, we have the parentheses C grouped around the cosine of 3. And it's not a typo. The cosine of 3, and you've probably never even seen that, but that's just a number. Because cosine, remember, you can take the cosine of a variable where you'll usually see the cosine of x, but the cosine of 3 will just be a constant, a number. So it's just this times the derivative of this. So you don't even need a chain rule. And let me just show you my calculator. Let me make sure the mode is right. Yeah. So if I take the cosine of 3, it'll just give me some decimal number. See? So it's just a constant. So the derivative of y with respect to x will be equal to the cosine of 3 multiplied by the derivative of x squared, which will just be 2x. And so that'll be your answer. Okay, now we have that y is equal to the cosine of 3x, and that's raised to the second power. So what's actually going on here is that the entire group 3x is being squared. See here, the square is only on the x, but here the square is on the 3 times x. So what this is actually, saying is that we have the cosine of 3x times 3x, the cosine of 9x squared. That's another way to write the exact same thing. Well, I don't know what is up with my pencil. Oh man. Okay, so we have y is equal to the cosine of 9x squared. So then the inside function is the 9x squared, the outside is the cosine function. So the derivative of y with respect to x will be equal to the derivative of the outside function, so the derivative of the cosine function, which is the negative sign of 9x squared, multiplied by the derivative of 9x squared, which is going to be 18x. And let's put that 18x in front, so negative 18x times, times the sine of 9x squared. All right, now in the next problem, we have y is equal to the cosine. We got this little 2 in a weird spot here. Now, again, remember with trig functions, they have a very unique way of expressing, whether they mean for the entire function to be, raised to the power of 2, or just the exponent, or just the variable. So when it's like this is basically saying that the entire cosine function is being squared. So this is the same as the cosine of x times the cosine of x. That's just the notation, and I need to find a new pencil or something. Because if they put the to make it that you don't confuse with the x being squared, so they put the 2 there. So what you really have here is just like a product rule. So you take the derivative of the cosine of x times the cosine of x plus the cosine of x times the derivative of the cosine of x. So Let's look at that. So what we're going to have is that dy dx. Let's first take the derivative of the cosine of the first one, cosine of x, which we know is equal to negative sine of x. Leave that second cosine of x as constant. And let me actually put that in pink. Make it clear what I'm doing. And then now I'm going to add, it to the cosine of x, leaving this as, my constant, so plus the cosine of x. And then taking the derivative of the second cosine of x, which is, still negative sine of x. And then so I just have the same thing twice. So I have just -2 times the sine of x times the cosine of x. So let's use -2 sine of x and these parentheses are making this look harder than it is. The -2 sine of x cosine of x. All right, just two more. All right, we have y is equal to the square root of the cosine of x. Let's just rewrite this first as, power. So it's just the cosine of x being raised to the 1/2 power. So you just got a chain rule. So your outside function is the square root function, or the 1/2 power. The inside's cosine function. So then dy dx will be equal to the derivative of the outside, which is going to be 1/2 times the cosine of x to -1/2, because you take away 1 from the 1/2, multiplied by the derivative of the cosine of x, which will be negative sine of x. And then it'll just be simplified as negative sine of x over 2 times the square root of the cosine of x. All right, so this last one is a cool one. This is a good one. We actually got 3 things going on. Let me rewrite this first. Let's remember what that 3 being there means. That means that this whole expression is being cubed. So it's like the sine of 4t times the sine of 4t times the sine of 4t, or the sine of 4t, if you put in parentheses, then you can put the 3 outside like that. So what you have going on here is that you have the sine function, you have the 4t function, and you have the cube function. So my outermost function is the cube function. The next one I have is the sine function. And the innermost is the 4t. So it's just chain rule, doing it, twice, like, or 3 times, however way you want to see it. So what we'll get is that f prime of t, I like to work from outside in. We take the derivative of the cube function, so I'll just see 3 times the sine of 4t, all to the second power, multiplied by the derivative of the sine function, which will just be the cosine of 4t, multiplied by the derivative of the 4t, the inside function, which will just be 4. And that'll be it. We just clean this up. It'll just be 12 times the sine of 4t all squared times the cosine of 4t. That's all there is to it.